Hello everyone. Let's start with a numerical, which is three-dimensional in nature, and the numerical belongs to a system in which we have got three forces which are acting in a 3D plane. Okay, and the numerical states that determine the angle theta. You need to find the angle theta such that an equal force is developed in legs OB and OC. Okay, so he says that this theta, he is interested in calculation of this theta, and remember this theta you need to calculate, and this force 100 pounds is acting in a two-dimensional coplanar concurrent plane. Okay, so it is in a two-dimensional plane, and this force is basically concurrent. Force is basically acting at point O, and it is basically a, you can see it is a coplanar force system. Okay, and this is one force is over here, and you have got other three forces, 1, 2, 3. They are basically non-coplanar. They are basically non-coplanar but concurrent in nature, because this is a three-dimensional force system. This is a three-dimensional force system, and these three forces are acting in a 3D plane, and so but they are concurrent, and since it's a 3D plane, so we'll call it as non-coplanar. But this force is basically acting in a 2D plane, and we can say it's a coplanar force system in which this force is acting at point O. So you must understand these force systems, very important. If you do not understand these force systems, you have to look at my videos in which I have explained the different types of force systems: coplanar, concurrent, collinear, and non-coplanar force system. You must go and watch those videos. I will show you when it will be coming on the right and left of the when you're watching the video. Okay, so you can just go and watch if you're not understood the force system clearly. Okay, now if you look at it very clearly, you have to understand how the forces are acting in solving this problem. We can assume any direction because no force direction is shown. Okay, so what we have done over here is that we will assume that the force in leg A, the force in leg A is acting starting from A and ending towards O. So we can say that force as that force can be called as AO. It will as force will be called as AO, force AO. Okay, and the other two forces we assume, again this is again an assumption. You must remember is that this force which is acting at C. Okay, we can call this force as OC, and the other force which is acting on this leg B. Okay, at leg B is called as force OB. Okay, so again, if we want to draw the FBD of this system, we can very easily draw it over here. Just to let you further show you the insight, this was the force F in a 2D plane, 2D coplanar force system. So it has two components. One component is this, and the other component is this, and this is the resultant. The Y component will be called as cos theta J, and the X component will be called as sine theta I. Very important. The other three forces, if you say, we have assumed that this is the direction of force AO, and again remember, this is a mistake by Mr. R.C. Hibbeler. This is a mistake by R.C. Hibbeler. This mistake must be clearly rectified, and it must be equals to, you can say it will be, it should be, if it make it over here, it should be F A O, which must be FAO. Okay, it must be FAO, and the other two forces, if you look here, are basically FOC and FOB, and again they are basically this is point C, this is point FOC, C point, and this point is this point. If you look at it, this is point B. Okay, this is point B, this is point C, this is point B, C, and this is A. The other thing is very important. This force of leg A, okay, the leg A is basically at this point. Okay, and all these legs, 3 legs, are 120 degrees apart, and the radius of this circle is 5 feet. The radius of this circle is 5 feet, and all these 3 legs are 123 degrees apart of the tripod. So the tripod legs are 120 degrees apart. Okay. Then again, very important, the coordinates of point A are very, very simple, because this is our origin. If we go down in the z axis, our A coordinate will be minus 10k. What about the 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 other coordinates of A? Okay, because this is where going in the z direction, it will be 10k, but since positive z is upside, so we put it minus. What about the I and j of A? It will be, again, this is the origin, this is going to be the x-axis, this is the y-axis. So we are only moving in the y-axis. So we will say A will be 0i, comma, and the y-axis is, again, this is from here, this is plus y. So this will be plus y, which means plus 5 minus 10k. These are the coordinates of A. Now the coordinates of B, you have to be very careful. We will assume that since the leg B and leg C are 120 degrees apart, the leg B and leg C are 120 degrees apart. So if we draw a straight line here, if we draw a straight line just parallel to the, if we draw this straight line, if you can see, if we draw this line as a straight line here, okay, so we can divide this 120 degrees into 60 and 60. Okay, we have divided into 60 and 60. We can do it because it's 120 apart. This is the center of the circle. The radius is constant. So we'll divide into 60 and 60. Okay, so now if we want to calculate the coordinates of the B point, this coordinate, we want to calculate the coordinates of the B point. So what we will say, this is the point B. Okay, so again, what will be the coordinates of point B? Again, the radius, you know, is going to be constant in the circle. So we will say the coordinates of B is going to be, again, this is very important. You must know that this is 60 degrees. So this straight line will be 5 cos 60. This is the radius, 5 cos 60, and this horizontal line parallel to the x-axis is 5 sin 60. Okay, so just look this triangle. Okay, so this is 5 cos 60, and this is the radius 5, and this is 5 sin 60. So the coordinates of B will be, if you move from here, okay, so what will be the component along the x-axis? Okay, it will be this component, which is 5 sin 60. Okay, this is 5 sin 60, but see, this is the origin, and we are going at the back of the positive x. This is the positive x. This is the origin. We are going back. So we'll put a minus sign, minus 5 sin 60. What about the y component? This is the origin. This is positive y. We are going on the back side of y. So we will say 5 cos 60. Okay, so it will be 5 cos 60, but we are going in negative y. So we'll put a minus sign. So minus 5 cos 60 j. And what about from the origin we go down? So we'll say minus 10k. Similarly, in the same way, we'll calculate the coordinates of this C point. Okay, when we calculate the coordinate of C point, it will be again this is 60 degrees, and you know this is the origin. Here for the x component, okay, we move, this is the x component, and this is the radius, you know, this is the radius. So this will be, again, the x component will be your 5 sin 60i. What will be the component parallel to y-axis? It is this one. This is the common component. Okay, it will be 5 cos 60 j. But since this is the origin, this is positive y, and we are going in the negative direction of y. So we will put for the minus 5 cos 60 j minus 10k. So if you understand these concepts of this numerical, the rest solution is very, very easy. So I am laying special emphasis of understanding this initial part of the theory. If you understand origin A, B, C, and how we have divided it, now it is very simple. You will first calculate, let us say we calculate the force AO. Force AO means you will basically calculate the position vector AO. Okay, so you will basically, when you do it, you will be subtracting the coordinates of the origin from the coordinates of A. Okay, so it will be what 0i again minus 0I, it will be 0I. And what will be the other thing? Because this is the origin, you will say 0 minus 5j, this is 0 minus 5j. And what about this one? 0 minus and minus 10k, 0 minus and minus 10k. So it will be plus 10, minus and minus gives you a plus. So this is RAO. Okay. Then if you want to calculate the position vector of this RAO, it is very easy. It will be the square root of minus 5 the whole square and plus 10 the whole square. So you will take the magnitude of RAO as 125. So if you take the square root of 125, you take the square root of 125, get 11.18. Now you want to convert this force FAO into basically a Cartesian vector force. So it will be FAO magnitude, and this is the direction, which is what is it is RAO divided by the magnitude of RAO. So what was RAO? Minus 5j plus 10k. What was magnitude of RAO? 11.18. So you divide minus 5 upon 11.18j plus 10 upon 11.18k. You simplify it, you will get the force FAO as force FAO equals to FAO magnitude 0I minus 0.4472j and plus 0.8944k. Okay, 8944k. Okay, so agar you can just say this is k. Okay, this is k, unit vector k. Okay, just this is k, 8944k. So now what we say is that we will be interested in calculating FOB. FOB, again, you know the coordinates of FOB. You have to take the position vector ROB. So if you take the position vector ROB, which means you subtract the coordinates of B from O. So it will be minus 576 minus 5 sine 60I minus 5 cos 60j and minus 10 minus 0 again k. So it will be again minus 10k. This is ROB. Again you take the mod of ROB, square root of the, take all this value square, minus 5 sin 60 square minus 5 cos 60 square and minus 10 square. So when you do that, you will get ROB equals to 11.18 also. It is the same coming as what it was over here, 11.18, because here it was 5 and 10. Now here is uh, minus 5 sin 60, minus 5 cos 60 and minus 10. Again it is by chance coming the same ROB, 11.18. So again you have got ROB divided by ROB. So FOB will be equals to, vector FOB will be equals to FOB magnitude into ROB divided by ROB mod. So it will be minus 5 760, 5 minus 5 sin 60I upon 11.18 minus 5 cos 60j over 11.18 minus 10 upon 11.18k. And you multiply it simply, you will get your FOB equals to, vector force FOB equals to FOB mod into minus 0.3873I minus 0.2236j and minus 0.8944k. So FOB's problem is also solved. Now we are basically interested in calculating this FOC, this force, FOC. So again we know the coordinates of FOC. This is O and this is C. It will be 5 sin 60I minus 5 cos 60j and minus 10 minus 0k. So it will be 5 sin 60I minus 5 cos 60j minus 10k. So again the same approach. You take the you have calculated ROC. Okay, you have calculated the ROC, and again you take the ROC mod over here. So it will be what? Minus 5 6 sin 60, square root of 5 sin 60 the whole square plus minus 5 cos 60 the whole square and plus minus 10 the whole square. Okay, so you simplify it, you again get ROC as square root of 125. It is 11.18. You say that vector FOC equals to FOC mod, and you take ROC divided by ROC mod, 5 sin 60I over 11.18 minus 5 cos 60j over 11.8 minus 10 over 11.18k. Okay, simplify it, you will get your FOC equals to, vector force FOC equals to FOC magnitude into 0.3873I minus 0.2236j minus 0.8944k. So these are the forces that you have calculated it. You can say this was your force AO, this is your force AO, this is your force OB, and this is your force this is your force OC. This is your force OC, force OB, and this is your force OA. Now this is being done again, but there is one force which is still remaining, and you know that force is this force. This force will have two components, F, this is positive X, positive Y, you can say F, 100 sine 60I plus 100 cos 60J. So you can see this force F equals to 100 sine theta I plus cos theta J, 100 sine theta I plus cos theta J as the force F. Say this equation is 1. Now you apply summation of all the forces about x-axis equal to 0, which means you add up all the x components at one place. Okay, if you add all the x components at one place, it will be here it is, you have to add all the x components at one place. So this is one component, okay, minus 0.3873. The other component will be again FOC, 0.3873I. These are the same but different directions, and one component will be for the x 100 sine theta I. So you add them. Here I add them. What I do, minus 0.3873 FOB, and again you will say plus 0.3873 FOC. Okay, this one, and then the other component you have just calculated it, for the x is 100 sine theta I. This is 100 sine theta equal to 0. So these components sigma fx equal to 0, you have added them. Now, but very important, you know that FOB equals to FOC. Why? Because in the question he is saying to you that he says the force F lies in the xy plane, and he says that you will need to calculate theta such that equal force is developed in legs OB and OC, which means FOB and FOC are equal. Okay, very important concept. So if you go here, you will write and you will say that since in this equation FOC equals to FOB, so if FOC is equals to FOB, then you can say that what will be happening to this theta? This theta will become 0. If this theta will become 0, this factor will become 0, and this, when this will be 0, then only FOB and FOC will be equal. Okay, so then only they will be equal. Very important point. We will say this theta will become 0. So here, since 100 sine theta equal to 0, and we say this theta equal to 0, okay, then only this condition will be validated, and we will say that FOB equals to FOC. Very important point. Now you sum all the forces on the y-axis. So which means when I sum all the forces on the y-axis, one of the components on the y-axis will be minus 0.4472 J, this component. The other component will be minus 0.2236 J, and another component on the y-axis will be again minus 0.2236 J, and one more component will be this component, the cos theta component, this cos theta component. So again these four components are there. Now let's add them all together. The first component minus 0.4472 force FOA, minus 0.2236 force OB, minus 0.2236 force OC, plus 100 cos theta equal to 0. Okay, but you know it very well that you have just calculated the value of theta equal to 0. So when you calculate the value of theta equal to 0, what will happen? At cos theta equal to 0, it will become only 100, because cos 0 is 1. So now your equation is coming out to be equal to minus 0.4472 FOA, minus 0.2236 FOB, minus 0.2236 FOC, plus 100. So this is your equation 2. What about now you calculate sigma Fz. When you calculate sigma Fz, is what will be the one of the Z components? Force AO. It will be force AO plus 0.8944 K. The other Z component will be FOB minus 0.8944 K. And for OC, the z component will be again FOC minus 0.8944K. So there is symmetry. Now you add all those z components. Okay, so you have three z components over here. 0.8944 FOA minus 0.8944 FOB minus 0.8944 FOC equal to 0. So equation 2 and 3 are formed. But remember a very important point, FO is unknown, FOB is unknown, FOC is unknown, plus 100. And again in this equation, FOA, FOB, FOC, you have two simultaneous equations and you have three unknowns, cannot be solved. But remember the point, they say very important point, that FOC equals to FOB. Since FOC equals to FOB, you can easily say that this force FOB, you can make this equation as minus 0.4472 FOA minus 0.2236 FOB, and again since it is equal to FOC, you can again say minus 0.2236 FOB instead of FOC, and again over here also you will say 0.8944 FOA minus 0.8944 FOB, and in place of FOC you again put minus 0.8944 FOB equal to 0. So now these equations will be left with two unknowns, FOA and FOB, and you can solve it. When you solve it, you will get FO equals to 149 pounds and FOB equals to 74.5 pounds. But since FOB equals to FOC, so FOC will also be equals to 74.5 pounds. So it's a very challenging problem with lot of concept. So I hope I have tried to make it as simple as possible so that you understand, and the only way you can understand it further is to solve it by yourself. This understanding will give you a more insight, my video, and then you solve it by hand. Okay, so this was the problem at hand, and I hope you have understood this conceptual problem, how we have basically solved it, and I thank you all very much, and I hope you all have a very good day. Thanks a lot.